Okay, so today's lesson on function notation is going to be shorter than yesterday, so hopefully you hung in there yesterday. Function notation is the ways that you can write these equations. You can write an equation other ways besides y equals 5x minus 1. So for a, f equals the coordinate xy such that y equals 5x minus 1 means the function is the set of ordered pairs x, comma, 5x minus 1. Another way, b, you state this: f of x equals 5x minus 1. That means the function value paired with x is 5x minus 1. The traditional y equals 5x minus 1, y is equal to 5x minus 1. D, x comma 5x minus 1, the set of ordered pairs x and 5x minus 1. For E, hold on. Okay. For E, f such that x maps to 5x minus 1. X maps to 5x minus 1. And f, the image of x for the function is 5x minus 1. So the pre-image, okay, let me swing this guy over here. The pre-image is x. Okay, so the image of x, which is known as the pre-image, I'm not writing anything, here we go. Okay, so x for the function is 5x minus 1. All of these, a through f, mean y equals 5x minus 1. They refer to functions in various ways for various reasons that you will understand as we get there. Like in composition of functions, you need to be able to refer to functions as f, g, and h to simplify things. So commonly, f of x is most commonly used. And f of x represents y, the output. Okay, so f of x equals x squared plus y is the same as y equals x squared plus 1. Okay, now if they ask you to find f of 2, that's their way of saying replace x with 2 and solve. Or actually I should say simplify. So f of 2 would be 2 squared plus 1, which is 4 plus 1, which is 5. So if you were to actually set up like an x and a y chart for the equation y equals x squared plus 1, if you have an x coordinate of 2, the corresponding y coordinate would be 5. So the coordinate 2 comma 5 is a point on the graph y equals x squared plus 1. F of 5 equals 5 squared plus 1. So 25 plus 1, or 26. So if x is 5, then y would be 26. That's an ordered pair on the graph x squared plus 1 equals y. F of negative 3 squared plus 1. 9 plus 1, 10. So when x is negative 3, the pre-image is negative 3. The image of that, the y coordinate, is 10. Another way to ask that is f of negative 3. F of a would be a squared plus 1. And that cannot be simplified, so that is the answer. And f of a plus 1, so I'm going to replace the entire x. So it's going to be a plus 1, quantity squared, plus 1. And then you would simplify that. So I'm going to FOIL a plus 1, and then add 1. So I get a squared plus a plus 1 plus 1, and this comes from the x squared. We're taking that x coordinate, a plus 1, squaring it. Combining the like terms there, we get a squared plus 2a plus 2. So that's what f of a plus 1 is equal to. Okay, so write an expression for f of x and then find f of 4. So for the first example, y equals x plus 3, the expression would be f of x equals x plus 3. That's simple. Find f of 4. So for f of 4, we're going to plug that in where we see the x. So it's going to be 4 plus 3, or 7. Okay? Next one was like the one from up above. The image of x for the function is radical x. That means f of x equals radical x, or y equals radical x. Same thing. So f of 4 would be the square root of 4, which is 2. So if I was setting up an x and a y coordinate for this, it would be 4, 2. For f of x equals x plus 3, it'd be 4, 7. Okay? Next one, x maps to absolute value of 2x plus 1 really just means y equals absolute value of 2x plus 1. So f of x equals absolute value of 2x plus 1. Okay, and now we want f of 4. So absolute value of 2 times 4 plus 1, which is the absolute value of 8 plus 1, which is 9. The absolute value of 9 is 9. So x coordinate 4, y coordinate 9. And then on the last one, that one means the set of ordered pairs x and negative 2x, but that really just means y equals negative 2x. So f of x notation would be f of x equals negative 2x. And then f of 4 is going to be negative 2 times 4, or negative 8. So that xy would be 4, negative 8. That would be an actual coordinate on that graph. Next page. So graph of a function. All right, so they're asking you to find f of 0, f of negative 5. So remember, on the previous ones, I had set up a x and y chart. So let me try to pull that up a little bit. So if I do that here, I'm looking for what is y when x is 0. So go over to the graph and look at 0, okay, and then go up to y. And y looks like 2.5. So that's the coordinate 0, 2.5. So when x is 0, y is 2.5. So f of 0 is 2.5. For negative 5, okay, so go over 1, 2, 3, 4. So 1, 2, 3, 4. So here, and go down. Okay, so that coordinate there is negative 5, comma, 1, 2, 3.5. So when x is negative 5, y is 3.5 or 3.5. So f of negative 5 is 3.5. Sorry, negative 3.5. F of 4, go over 1, 2, 3, 4, and go up. That coordinate there is 4, comma, 0.5. So when x is 4, the y was 0.5. So f of 4 is 0.5. X comma y, x comma y. Last one, f of negative 1. So when you go to negative 1, then you have to go up. So you have to, go up to find the graph. So that coordinate is negative 1, comma, 1. So negative 1, comma, 1 would mean that f of negative 1 is positive 1. When x is negative 1, what's y? All right, for domain and range, we are looking left and right for domain. We're looking at all our possible x coordinates. This coordinate farthest to the left has a coordinate of, I'm going to count it out here, 1, 2, 3, 4, 5, 6, negative 6, comma, 1, 2, 3.5, negative 3.5. This point farthest to the right has the coordinate 1, 2, 3, 4, 5, comma, 0.5. So wouldn't you agree if you look at all the other x coordinates, they are numbers between negative 6 and 5. So the domain goes left and right from your smallest to your largest. And since they are all connected and they're not like pointing away from each other, it's a conjunction or an and. So we say the domain is negative 6, less than or equal to, because it's closed circle, x, less than or equal to 5. I'm looking at my total possible x coordinates. Now for my range, okay, so the negative 6 affected my domain and the positive 5 affected my domain. But I'm looking for now my lowest, my smallest. I could look at it here or here. Those are the y coordinates that would represent the smallest. And you might think it's 0.5 over here, but there's a larger y, which is 2.5. So this 2.5 is going to be also my largest value in the range. Every other y coordinate, if you look, is between negative, that needs to be negative 3.5 and positive 2.5. So my range goes, my y coordinates go from negative 3.5 to 2.5. I'm looking up and down. You look up and down for range, and you look left and right for domain. There's no arrows, so I'm not going to say all real numbers because it actually has a beginning and an end for both x coordinates and y coordinates. All right, that concludes the lesson for today.